Well, good morning, everybody. It is nice and cold here. I don't know what it's like where you are, but it's cold. Today, I want to talk about gravity again, one more time. It seems like Anthony Riley just doesn't get it. Uh, Obviously, he's not paying attention. Uh, he has what he wants to believe, and he's not going to change his mind. Flat earthers always ask, show me the proof. Where's the proof? So, if gravity doesn't exist, where's the proof? Well, let me show you. Our past videos, we've done 6, including this one. We talked about atmospheric pressure, the pressure of the atmosphere, the gradient, which cannot exist if there's a dome. Uh, Pressure versus gravity. We've talked about the oceans and the continents. Absolute proof of gravity versus density. We did our gravity experiment along with Andy Flatter. Uh, I did This Is Your Life, Anthony Riley. We did the gravity lesson one more time last week, and we're doing the gravity summary today. So far, I have shown you, I think it's pretty clear that atmospheric pressure is caused by the weight of the gravity of the air above. So uh, if we start at the edge of the atmosphere, as we come down toward the planet, the, the air that's above weighs down upon the air below it, and so the pressure gets higher. Uh, it cannot be density. Hydrostatic pressure. This is the oceans and the lakes, water. It's caused by the weight of water increasing as depth increases. So just like the atmospheric pressure, you start at the surface of the ocean, and as you go down deeper, the pressure gets higher. And any uh, diver will tell you that. Uh, Even in a swimming pool, you can feel that change in pressure. Uh, Lithostatic pressure, this is the solid ground, continents and the seafloor and anything else that's solid minerals. Uh, this is caused again, one more time, by the weight of solid ground increasing as you go deeper. So deeper and deeper toward the center of the earth, uh, the solid ground uh, pressure increases. This is the cause for volcanoes and earthquakes. As the pressure increases, uh, causes that pressure to escape. We've done 2 live experiments showing that gravity causes things of different densities, different masses to drop at the same time. There's no question by watching that uh, it could it could be caused by density. Uh, we compared mass versus weight and buoyancy. Mass is an intrinsic property of matter. Weight is caused by gravity. Weight is mass times the acceleration due to gravity. weight and mass are not the same thing, and you need to be aware of what you're talking about. Buoyancy is an upward force, causes balloons to uh, escape the atmosphere. Gravity is a downward force, uh, causes you to fall when you jump off a mountain. So we also showed density, relative density are not forces. Get that in your head. Density and relative density are not forces. Density cannot make your uh, glass fall off a table. It's a basic, density is a basic property of matter, and I showed you that you can look up density uh, in a mineral table. So here's something I never showed you before. This is what things is gravity used in. Here I have 24 different things that gravity is used for, and gosh, can you imagine the problems that we would have if gravity wasn't the cause for these kinds of things? Uh, if you have a specific item that you're wondering about, you can look it up and they will explain to you what it's about. Um, so here's another good question that flat earthers, especially Anthony Riley, always bring up. Does Einstein gravity supersede Newton? Uh, it's so frustrating when you hear people say, oh, we can't talk about Newton anymore because Einstein uh, superseded that, so Newton is old news. And that's not true. So here are 4 quotes from different physicists. These are different people that have quoted uh, about gravity. So first one, there's really no such thing as a conflict between those theories. General relativity is simply an improvement over Newtonian physics. There are 2 main differences which lead to different results. In the case the gravitational field is very strong or velocities are very high. Unlike Newtonian theory, gravity does not act immediately but acts with the speed of light. In general relativity, the gravitational potential is affected by relativistic effects. So that's one quote. Um, so basically, you're talking about the gravitational field surrounding a planet or a black hole or something like that, uh, where Newtonian gravity doesn't quite uh, cut it. So here's another quote. I think he's answering some question because he says, so the question was, what would have to be adjusted to solve this conundrum, Maxwell or Newton? Again, you can look up Maxwell. It turned out that Newton was approximately right. There's an approximation of a theory which is now known as the theory of relativity. Here's another quote. Now, as for the differences, Newton's laws explain what happens when large things move slowly. And this is all relative, you know, when you're talking slowly, you're still talking what seems large to us. large um, a large thing doesn't necessarily have to be planet-sized. Large can be relative. Even a tiny ball bearing has to follow Newton's laws almost perfectly. Uh, Here, large means more than a few million atoms. Okay, and the last one, this is pretty good for those of you that are math freaks. Uh, this guy says, I did the math at one point running a Taylor expansion of the special relativity equations of motion. Turns out you end up with the Newtonian ones plus an IIRC fourth order remainder. That means a very small remainder. So Newton's equations are pretty useful approximation of special relativity for low velocities. You can imagine in one of those previous uses of gravity, you could imagine them trying to use the special relativity equations on an everyday basis. Newton is clearly much easier. Here's a picture of gravity at work. This is the Albuquerque International Balloon Fiesta, which is going on right now. But it shows you buoyancy. All of these balloons are filling themselves with hot air, which is buoyant. Another thing that good old Anthony Riley brings up constantly is that gravity is not real and it's not a force. Anthony Riley is splitting hairs here, and he uses a lawyer's point of view of proof, not science. I cannot quite convince him that he's not a scientist and he doesn't understand how science works. His idea is to find one problem spot and invalidate an entire scientific theory or even the scientist. In court, the lawyer, if there are 200 proofs and one of those is invalid, it proves guilt. However, in science, if there are 200 proofs and one is invalid, then something went wrong. There's some missing information. You didn't do it right. So gravity is very real according to both Newton and Einstein, and then even theoretical physicists currently, every one of them believes that gravity is real. You will not find any scientist that says there's no such thing as gravity. Is gravity a force? Now here, at this point, there's vast confusion. In everyday reality, 3 dimensions, yes, gravity is most definitely a force. There's no question. You can't work with everyday items like we saw before. You can't work with those without the force of gravity. This is the only thing that can exactly explain multitude of places where force causes motion. And these again are Newton's laws of motion. You just can't throw those out. Now, beyond the everyday, there is general relativity, which does not negate Newtonian gravity, and we saw that in the previous slide, but it adds immense complexity. So in this case, no, gravity is not a force, but I promise you, I tell you for certain, if Anthony or anybody else wants to go this route and say, no, gravity is not a force, scientists don't believe that, this person's got to explain space-time and curvature of space-time, because that's where gravity fits in. It's in the fifth dimension, so you have to know what 5 dimensions are, tensors, how gravity works like an electromagnetic force, and quantum mechanics, among other things. So you have to be able to explain these things. Otherwise, don't tell me that gravity is not a force. This is very advanced theoretical physics. This is on the realm of Einstein and Stephen Hawking and people like that. So unless you're on that level of education and experience, don't try to tell me that gravity is not a force. So this is my conclusion. This is me personally. I am not a physicist. I'm well acquainted with science, but I am not a physicist. But for the three-dimensional world that we live in right here, gravity is a force, and it's accurate compared to relativity. It's accurate to a 4th degree level of error, and 4th degree is 0.0001. So yes, gravity is definitely real, and it's definitely a force. Now, I bet you thought I forgot the joke of the week. This one only has one line. So my 3 favorite things are eating my family and not using space commas. My 3 favorite things are eating my family and not using space commas. I'll let you think about that for just a second, because it might be a little hard to grasp. So this has been a good week. I think we've pretty well wrapped up gravity. Next week, I have planned This Is Your Life for Nathan Roberts. And then next Friday, I want to talk about ethics and science. So stay tuned for those things, everybody.